Again, this is a presentation on performance fiber reinforced concrete. Let's see if we can get this to work. And there we go. Just a quick overview on who FiberForce is. We are a manufacturer of fibers, and that's all we do. We've been doing it since the mid-90s. We actually made fibers for most of the admixture companies and just third-party bagged it. But about 8 years ago, the company decided to take a different direction and hire technical sales managers like myself to push the specifications to the design community and to the contractors. So we have 4 engineers on staff along with 10 technical sales managers like myself. So a little history on fibers. They've been around since the ancient times. As a matter of fact, they used horsehair and straw for mortar and mud bricks. The Romans used it in their building practices. I got this photo here. It's obviously a newer building, newer church in New Mexico, but I would show in the stucco, they're actually using straw for the shrinkage fibers. History, again, back in the 1900s, fibers, asbestos fibers were used until the 50s. They realized that that A word had some health risks. So in the 60s, they came out with steel, glass, and polypropylene fibers, which are still used today. But why? Because there's 3 absolutes in life. You will die, you're going to pay taxes, and guaranteed your concrete will crack. But there are crack addicts out there that like cracks in their concrete, but most of us would like to control that. But typically, why does your concrete crack? There's really 2 main reasons. The first is shrinkage, and the other is restraint. So does anybody know this famous quote? Of course, no one can answer me because you all are muted, but it's our friend George Costanza. Basically, what I'm saying here is that the Portland Cement Association, the PCA, says that over 100 lineal feet, your concrete will shrink about 5/8 of an inch. But again, that's not why it cracks. It's because of restraint. If your slab was on rollers or suspended in space, you wouldn't have cracks in your concrete. Other reasons is water convenience. If you see a finisher out on a job site that is got a bucket and a brush and is blessing the slab, you're going to have some issues on the surface. Improper jointing, meaning that it's the joints aren't cut deep enough or too narrow or too shallow. Also the joint spacing. If it's too wide or too narrow, you're going to have cracks jump out of that joint pattern. We talked about restraint. You got wind. Low humidity will contribute to cracks on the surface, along with high temperatures. Now I got poor subgrade there, but that's not the vertical cracking, which I'm talking about with shrinkage. That's horizontal. But here's my biggest challenge as a territory manager is break tradition. I've got folks that swear that they need steel reinforcement in their concrete. The fact of the matter is that on flat work, whether it's on grade or up on composite deck, the steel reinforcement in that slab is there for secondary reinforcement, not primary. Secondary meaning that it is there for crack control and containment. So I got this up here. It says I showed my 12-year-old son an old floppy disk. He says, wow, cool, a 3D printed version of the save icon. I got this up here because we are involved with the universities to get the younger design community and construction professionals educated on the need for taking a look at fiber as a secondary reinforcement option. But why consider fiber reinforcement? I call it the 3 Ps: performance, productivity, and profit. And we'll get into these reasons in more detail. So why are we reinforcing slabs? Again, we're there to not ensure that there won't be any cracks. We're just to make sure that those cracks are held good and tight. Big thing in my world as far as being a fiber representative is to extend the joints. Again, we're not there to prevent it. Maintain slab tolerance and impact and fatigue resistance. Again, I've got poor soil conditions. Sometimes when I take a look at a slab that's got double mats or rebar, the first question is why is the lower mat of rebar there? And most likely it's there because of the poor soil conditions. That's something that probably should remain in place because it is more of a primary reinforcement option. Same with structural slabs on ground. Again, when we're talking about impact resistance, shatter resistance, improved fire performance, we are in a lot of shotcrete applications, and what happens there is when water freezes, it expands 9% of its mass. So that's why on the bottom of water bottles there are little dimples. So when it does freeze, it expands and doesn't explode that bottle. Well, that's why we put air entrained concrete or air entrained admixture in exterior concrete for the freeze thaw. Well, guess what? That's the same thing that happens when fire is exposed, or the concrete is exposed to fire. That water or moisture in the concrete will expand and create more of a hand grenade explosion. So we'll get into some examples there. This is a sample of impact and fatigue resistance. It is a very thin sample, and the hammer is being dropped, just gravity. There is no fibers in this sample, and it kind of looks like that Ford commercial at the end where the logo drops on top of it. And the next sample is the same size sample, but it's got some macro fibers in there. Essentially what's happening is the fibers are absorbing the energy of that impact. And so when you start taking a look at any type of environment where there's impact or fatigue resistance, fibers will help with that in your slab. Taking a look at the fire. Whoops, let me turn that down a little bit. So again, when fire is, concrete's exposed to fire, it will expand the water and start popping. And so in structural concrete, we're not replacing any reinforcement because that is primary. We're just adding to it. And the reason is because this top sample had fiber in there, and that fiber will melt and create more of a wicking or a breathing of that, that concrete member. And you can see that in the top sample, whereas the lower sample here did not have any fiber and went ahead and spalled and expanded and exploded. Settlement. We also use, as we know, when concrete with gravity, the coarse aggregate will settle. And here is an example of a traditional reinforcement where we've told it to go ahead and crack. What we have is a void here, and that's where the moisture will gather and will start eating at the steel reinforcement. And what will happen with fiber is you will get a uniform bleed. So if you are on a slab, you're not chasing the bleed water like you typically would with a non-fiber reinforced slab. The other thing is it will take a little bit longer to get to the bleed water, get to the surface. I'm not talking hours. I'm talking have another cigarette and a soda and then get on it, because it has to, all that water's got to go around the fibers that are in the concrete. The other thing that it will do, fiber reinforcement will do, is help suspend that coarse aggregate throughout the matrix of that slab. And here's an example where you've got this sample here has, as you can see, has fibers in it, and the coarse aggregate is there on the surface, and that is your wear surface. So you're talking fatigue resistance, whereas with gravity, the coarse aggregate has settled, and your wear surface is now your fine aggregate. So the Welded Wire Institute, they'll tell you that the traditional secondary reinforcement, the steel, needs to be in the upper third of the slab, and it needs to be uniform. And the reason is when the crack happens at the surface, it's looking for relief, so it is looking down. And when it gets on, it grabs onto the traditional steel that is in the concrete in the upper third of the slab, it will stop opening up. Well, in order to get it uniform and in the upper third of the slab, you need to chair the concrete the steel reinforcement every 2 to 3 feet. And typically that never happens. And whereas the reinforcement, it's always at the bottom of the slab. So that crack is looking for relief, and it finally finds it at the bottom of the slab. And that means that crack has opened up nice and wide for a lot of things to happen. And what this slide will show you is that ACI 360 says that if the crack opens up more than 0.04 inch, you start losing aggregate interlock. The Welded Wire Institute also says that it is impossible to hook up the traditional reinforcement, the steel. So the nub on the end of a come along, you might as well snip that off, because there's no way you're going to grab that wire and pull it up and have it be exactly in the upper third, let alone uniform. So here's an example of a job site. You're going to have construction traffic on it. This is probably a ready-mix truck. And as you can see, I'm counting 1, 2, 3, 4 supports. Everywhere else, it doesn't appear that there are any. And if you look right there, that support is leaning and probably will fall as soon as the weight of that tire gets on there. Obviously, this sample is a poor subgrade issue, but that is something that can happen. This is a laser screed. They're fantastic pieces of equipment. They've really revolutionized the placement of mass concrete. You can really discharge a bunch of concrete in front of that machine and it can blow and go. But unfortunately, in this photo, if you look at this gentleman here, he's got the welded wire caught in his auger. So he's got his 10 snips and he's snipping that out. And there's some space, so there's not going to be any overlap of the reinforcement. And so you've got them just stomping that down and off they go. This looks like a 6x6 square, and that's probably a 4-gauge mat of welded wire, and they're chairing it, but that weight of that concrete is pulling it down. And they finally stop trying to wrestle with it, and they kick the supports out, and the laser screed is off and going. So there it is at the bottom of the slab. This is obviously way at the bottom of the slab, so much that it's getting buried in the subgrade. This is a complete waste of money and isn't doing anything for crack control. It's there because their great-grandpappy and their great-great-grandpappy had steel and concrete to make it stronger, and they don't understand the reason why that is there. This is a Walmart, actually. It's a sidewalk outside of a Walmart. That's a 4x4 square by 4 gauge. Obviously very expensive, and it is on the bottom of the slab. I'm not seeing any supports or any effort to chair that properly. And again, complete waste of money. Even up on composite deck, they've got supports there, and that 200+ pound individual, when he steps off that welded wire, it's not going to jump back into place. This guy's a chiropractor's dream. He's standing on 2 mats of rebar while he's trying to pull them up. Again, virtually impossible and not going to happen. And another example of waste of money. This crew decided not to even mess with the welded wire. They went ahead and put it underneath the visqueen. So talk about a complete waste of money. This is a prime example. And I got this because the welded wire is always the one of the first things to show up on the job site, and it never is freshly galvanized when it gets introduced to the concrete. And this example here, that rust is going to be virtually impossible to get off that slab. So this is also from the For Construction Pros. It's talking about the shortage of labor. So I'm getting some requests because there is a shortage of labor to go ahead and use fiber reinforced concrete because they can't find the individuals to come out and either tie the mats or rebar, let alone drag the watered wire and place it on the bottom of the slab. So I guess why deal with those types of issues? Why not go ahead and have it furnished and installed in the ready-mix truck? It does come in water dissolvable bags. So when it calls for 3 pounds or 5 pounds per cubic yard, if the driver puts in the proper amount of bags, I can put my hand on the Bible and say there's enough fiber in there to satisfy the requirements of the design engineer. ACI 360 does recognize the use of polypropylene and steel fibers for well over 30 years. But let's go ahead and take a closer look at fibers in the concrete. So if you get anything out of this presentation, just know that there are basically 3 types of fibers. There is a microfiber, a macrofiber, and a steel fiber. Micro, macro, steel. Now, when you take a look at the micros, there are 2 types of micros. There is a monofilament, which is this sample over here, and essentially the fibers are mono, meaning singular, and they are, in a microscope, they look like a smooth dowel. So you and I, pulling on a smooth dowel, it's going to come out of one or both of our hands, and that's what it does in the concrete. Typically, I see the dosage rate for the monofilament at 1 pound per cubic yard, and the applications are such like a driveway, or I'm sorry, a garage slab or a basement slab. Now, this other sample to the right is a fibrillated fiber, and as you can see, it's like an accordion. And as it gets mixed through the concrete and grabs onto the coarse aggregate, that accordion expands, and at 1.5 pounds, the fibrillated fiber can replace the 6x6 by W 1.4 or the 10 gauge water wire. So where I'm seeing the 1.5 pounds of the fibrillated fiber being used is sidewalks, your driveway, those types of applications. So remember, micro, macro, and there are 2 types of macro. There is the tape fiber, which is this sample over here, kind of looks like shredded masking tape, and then there's the stick fiber. Now, the tape fiber, typically the minimum dosage rate we see is 3 pounds, and at 3 pounds per cubic yard, I can replace 6x6 by W 2.9 by W 2.9 or the 6 gauge welded wire. The recommended dosage rate for a macro or a tape fiber is 3 to 5 pounds. 3 pounds is about the size of a couch pillow. Once you start getting into the 5 pound range, there could be some mixability issues and finishing issues that I might steer you towards the stick fiber, which is this over here. And the dosage rate I see utilizing the stick fiber is 5 to 10 pounds. Again, when you're talking to your ready mix producer and you are at the 4 to 10 pound range, there's got to be some discussion with the QC department on the mix design to make sure that the mix is optimized to the use of macro fibers, and that's where your fiber representative can help you out. Micro, macro, and steel. And like the micro and macros, there are 2 types of steel fibers. There is the type 1 fibers, which are these 2 here, and there is a type 5 fiber. The type 5 fiber is a stamped fiber, and I typically see that in a light commercial application. Minimum dosage rate for steel fibers is 25 pounds per cubic yard. And so with that stamped fiber, if you take and bend it in your fingers, it'll bend and break real easy. And so that's where I see it in the light commercial applications, whereas the type 1 is a cold drawn steel fiber. And I see that in more heavy industrial applications. taking that in your fingers and trying to bend that, it is very, very difficult. So I see that like in steel mills. The most I've done is 89 pounds per cubic yard. And my European counterparts kind of laugh at that because they're over 100 pounds per cubic yard. But they also don't utilize the macro fibers as much as we do in the States. And they are more accustomed to mixing and finishing the high dosage of steel fibers. So when you take a look at the line of fibers, again, micro, macro, steel, there are some blends, which basically takes a look at the micros having the early age performance, the first 24, 48-hour temperature plastic shrinkage. And then you got the long-term performance, which is the crack control and containment. And with the engineered blends, you get the best of both worlds. You get the micro macro blend or the micro steel blend. Again, there's no obstruction to the sub base. It's ease of placement. You can go ahead and discharge your trucks right on grade. Safety is a big thing. You've got your EMR ratings that these facilities such as BP, you've got Eli Lilly, ArcelorMittal that require your EMR rating to be at a certain rate or below. And once you go above that EMR rating that is their threshold, you are not allowed to do work in their facility. And certain things like cuts and scrapes and back issues with traditional steel is chipping away at the EMR rating. So again, there's always with safety, but there's the fiber is positioned where it will be compliance with the code. We can reduce labor costs, so there's no rod busters out there. So it is furnished and installed when it shows up in the ready mix truck. I can speed up your construction schedule, that I'm not having to wait on rod busters to tie mats or rebar or drag the watered wire out and put it on the bottom of the slab. So let's take a look at a couple watered wire projects. This one here, you can kind of see that they, in the beginning, they were sharing it okay, and then they kind of got away from the 2 to 3 foot spacing. And essentially what will happen is that you'll have this issue where the wire will pop up because of the weight of the concrete and the overlap. And so now there's an issue that the finisher will have to go out there and stamp that down or snip it out. And that then when they do that, then you've got some issues of overlap or lack thereof. Safety, this project, they were cutting this all in one cut, the 6x6 2.9 watered wire. They're putting it in a sidewalk, and so again, safety hazard. There was no eye protection at this time. So again, look at your EMR rating. Here's another job where they go ahead and have the expense of bringing the chairs out there, but that welded wire is not the chairs are not at the 2 to 3 foot spacing. And here they are going ahead and placing it. And as you can see over here in the corner, the weight of the concrete is just lapping it over the chair. And so again, this is an application that is a complete waste of money with the watered wire. Again, one of the first things to show up, it's rusty, and here is an example of them dragging it through the mud. They're bringing it on in. Again, back issues, cuts and scrapes. These two guys are double productive, carrying double or 2 mats of watered wire. They're plopping it down. This guy looked like a bald eagle as he was walking across the visqueen with that flopping in the wind. And here they are flopping it down, and those Georgia buggies are ready to go. And I see no attempts to get that off the subgrades, so that's where it's going to stay. And that, in my opinion, is a very, very expensive way of holding down visqueen. you might as well take the owner's wallet and bury it in the concrete because, again, it's a waste of money. And I can tell you it's going to look like that at the bottom of the slab. So then there's this application. Well, geez, they're even taking the effort to bring the water wire. And to me, why even mess with it? If you're gonna form that up like that, why even add the weight of the welded wire? So have it furnished and installed in your concrete. Placing it, you don't need any new equipment. But there is always the number one question I get with fiber reinforcement is what? And that's, what about the hairy surface? So on the higher dosage rate, the lower dosage rate, we typically don't see much issues with fibers at the surface, but there is a technique, and it's not very difficult. It's basically you strike it off and you wait till that bleed water leaves. I can walk a slab, and if it's real hairy, that means they got on it too soon before the bleed water hit that surface, and that cement hadn't had time to grab onto the fiber and hold it down, and that when they were doing their finishing practices, essentially all they did was comb the slab. Now, that is not the end of the world. You can come back and burn that off real quick. Another technique when you get into a higher dosage rate of fibers is to use a roller jitterbug. And after you bowl float it, you come back and you roll this across the top of the surface, and that will knock those fibers down. You throw another bowl float finish on there. But again, the key is to wait for that bleed water to leave the surface before you start your finishing practices. Again, your finishing types, you can hand trowel it, you can power trowel it, you can broom it or tine it. When you're brooming and tining it, to wait as long as you can is of the most important. And when you broom it, don't broom it two ways. If you're pulling it like this example, only pull it one way. You pull it back the other way, you will comb the slab. And you will see some hairs stick up, but it's not the end of the world. It's an exterior pavement. The sun, the effervescence will help get rid of that, along with your snow plows, that if you come back after a winter, you're not going to see the fibers on the surface. Now, I have made some claims that X amount of pounds replaces Y reinforcement. We are measured, the fiber industry is, by a number of different tests. There's two main tests. One is the ASTM 1399, which measures residual strength, and then there's the ASTM 1609. The real difference between the two of them is that this sample here is a beam that's this size, and they've got it's 3-point loaded, but they've got a steel plate underneath there, and they apply the PSI to the top of that until it initiates that first crack, and then they remove the steel plate and they continue to apply PSI down until that piece is in two pieces, and they measure over a number of different samples how long it took that and how much deflection that occurred to come up with an average residual strength. The 1309 again measures the flexural strength. There is no steel plate. It is 3-point loaded, but they apply PSI, release it. Apply more PSI, release it, et cetera, until that piece is in 2, and they come up with an RE3 or a flexural strength ratio. The most common one that we see is the 1399. That comes up with the average residual strength, and here it is with the steel plate. The crack is initiated here, and then they measure again the deflection, and they stick it into a fancy formula to come up with the average residual strength. Another thing to keep in mind is that fibers do not hurt, nor does it help compressive strength. We are there for crack control, not for compressive strength. So you could have a sample, a beam of like 50,000 PSI compressive strength, but if it doesn't have any reinforcement in it, any fibers in it, it has zero residual strength. And when you start adding fibers is where you start getting that assistance and that crack control or residual strength. Again, when you take a look at the full range of products and take a look at the applications, residential slabs with the 1.4, we've got some options for you, light commercial with the 10 gauge water wire, or you get into the 6 gauge or rebar, heavy industrial slabs. Another application that we're in is the state DOTs are taking a look at overlays, whether it be 4 to 6 inches. They're going right over the top of asphalt in mainline pavers, and they're going anywhere between 4 to 5 pounds of the macro. And they're going through mainline pavers. There is no dowel baskets because they don't make them that small. And with the miles that they're doing the overlay, it would be very expensive to have dowel baskets. So they are going with the 5 pounds of macro. Then there's also topping slabs. When you're looking at over PT slabs or precast, to go 2 to 3 inches over the top with the traditional steel in the upper third is nearly impossible. So we are in quite a bit of topping slabs. Bridge decks, we are not replacing anything in a bridge deck. We are just extending the life of that bridge by holding the cracks tight. So when you look at applications like Oregon, they've got it in their specifications that the cracks that come off the vents, the corners, that prevents the de-icers from getting down and into the reinforcement and corroding that. Also, the studded tires that they have out in Oregon and the slam drag of a snowplow, we're able to help with that impact and fatigue resistance and maintain the integrity of that bridge a lot longer. Here's an example of a overlay that we did in Kentucky, and this was 5 pounds per cubic yard. And as you can see, there are no dowel baskets. They're going straight on top of the asphalt. The thing that they did learn pretty quickly is that the amount of saws that they need out there need to be increased. As a matter of fact, more than doubled, because at 6 inches, that piece of equipment there can lay some concrete real quick. My number one sales tool, though, is my calculator, because when you take a look at comparing the welded wire to the fiber, as far as the cost, you're looking at the fiber being bid per cubic yard, and the welded wire or steel always is bid per square foot. And so when you take the 6x6 by W 1.4 or 10 gauge welded wire, and you compare it and you put it in at 18 cents per square foot to furnish and install it, in a 4-inch thick slab, that's going to cost you $14.58 per cubic yard. And essentially that's because in a 4-inch slab, that covers 81 square foot per yard. But let's flip it and reverse it. You've got 18 cents per square foot for the 10 gauge welded wire, fibrillated at 1.5 pounds. WAG number is around $10 per cubic yard. Obviously, as I get thicker, the slab gets thicker, the fiber gets more expensive because we are throughout the matrix of that concrete. But even at 6 inches, we are very, very, very competitive, and it is guaranteed to be in the right location. Again, taking a look at the full range of fibers, there are certain contractors I do not want my fibers in because they will not listen. And this is the type of crew that I would much rather them have their fight with welded wire, because they're not going to listen. And all you need to do is take the recommendation of your fiber representative and listen to their finishing techniques, because there are good cooks and bad cooks out there, meaning contractors. The cake mix is the ready mix concrete, And when it comes out, there could be the Betty Crocker cake mix. Person A can make it taste great. Person B can burn it and not taste great. So this is an example of a macro fiber, the tape fiber at 3 pounds per cubic yard. This is a integral color exposed aggregate driveway. So if you're going to see any failures, any fibers sticking up or visible, this would be the application. Now, my wife can walk over this slab and not see a single fiber. Myself, I can pick up a couple fibers visible, but you come back next year after the snow plow and the sun has attacked that, you're not going to see it. So there's an example of a good cook. When you take a look at the stick fiber, this is a integral color stamped concrete driveway, and it is 3 pounds per cubic yard. And this would be ideal to see any imperfection as far as fiber sticking up, but we've got a good cook. Taking a look at another picture of a patio that's got the 3 pounds in it. We are 3-dimensional as far as fibers. They're throughout the concrete as opposed to the 1-dimensional with traditional reinforcement. We are 100% going to be at where the crack occurs. Now, for me, I'm not a big fan of joining. Here's an example of a 3 pounds per cubic yard. When I was a contractor and we took a look at like gymnasium floors or office floors where there was a joining pattern on the drawings, I always questioned why, because where do you typically get your curl? At those joints. And as a concrete contractor, the flooring guy will not touch that slab until he's got a good FFFL number. And at those curls, I always had to come back and grind those joints down, which was not in the in my bid. So I'm suggesting to go ahead and let it crack. And what we're doing is we're holding those cracks good and tight, and you're going to cover it up and it won't be visible anyway. If it's in my driveway, yes, I want to control where that crack is. But if you're going to cover it up with flooring, what does it matter? So again, this is a sample. Look, there's some cracking, guarantees in life, remember, and where it finds, where the concrete cracks, it immediately finds relief with the fibers and stops opening up. Here's another example, but they went ahead and jointed it and it jumped out of the joint pattern. And my guess is because the joints are spread too wide apart. And I guarantee my paycheck, which isn't very big, but I guarantee that the welded wire is on the bottom of the slab. It's looking, that crack is looking for relief, and it found it at the bottom of the slab. I've got this project up because it is with lightweight concrete, and it is up on composite metal deck, over 1 million square foot. And there was no issue with the lightweight, let alone pumping it. Jack Daniels is at 7.5 pounds per cubic yard in their warehouse. Just last year, they're throwing obviously macro fibers in their concrete because they recognize the utilization of fiber reinforced. And then you take a look at the new hospital at Franciscan in Michigan City, all has 4 pounds per cubic yard of a macro fiber in it, up on composite deck and up on or down on the slab on grade. Again, getting my calculator out, when you take a look at 3 pounds per cubic yard is $18 per yard in a 6-inch thick slab. That's 33 cents a square foot. And I don't think you can purchase and install 6-gauge welded wire for 33 cents a square foot and guarantee it's going to be in the correct location. The Steel Deck Institute does recognize the use of fibers. The Steel Deck Institute design manual does recognize either 25 pounds of steel fibers or 4 pounds of macro fibers. So that's why we are in a lot of composite metal deck applications, is because the Steel Deck Institute recognizes the value of fiber reinforced concrete on their decks. However, if you're taking negative moment steel, you're considering on taking that out because you have fiber in there, I will caution you on not doing that. The railroad ties there, or the negative moment steel on either side of that girder, is there for because of the flex of that deck. If you do not have the negative moment steel, I guarantee you will have cracks on either side of that girder because of that flex of the deck. Here's a project that I was involved with back in 06, 07 for Duke Realty. This is a spec building that stood like this for a while because that's back when China was having their big building boom, and steel was in high demand in China, and they were having a hard time getting the welded wire, and Duke finally asked for an alternative, and that was fiber. And the contractor actually gave money back because they didn't have to wrestle with the fiber up and install it on the decks. And so Duke had me come in along with the producer and contractor and give a presentation not only to their construction project management, but also their realtors, because they noticed that the cracks off the corner of the columns were drastically reduced, and if there were, they were held good and tight. And so in a spec building, Joe Public didn't see these wide cracks opening up and think there was a defect in the building. This was a project that I was involved with in Chicago. It's for the Blue Cross Blue Shield building. Essentially, they were in their building for 12 to 13 years, and they decided to expand up. And so they just started stacking steel on top of their building. This here is where their condenser units are for the lower portion of the building. And they had a huge concrete pump down on Lower Wacker Drive, and the pump hose went right through the center of that building. And all you heard was a slight knock every time they were placing concrete. And it was kind of cool because those actuarials didn't realize the thousands of yards of concrete screaming by them. But there it is going up. And as you can see here is the where it was original building, and here's the new building. And they did not want to mess with the welded wire because they want to have it swung over the streets, let alone block off the streets and that expense. So they chose to go with 25 pounds of steel fiber. Again, this was back in 08. And so you can see here's the beam. This is how high up we were. Here's the taste of Chicago. This was up on the 71st floor, and I think it went up to 86 stories. I bring that to your attention because that's the second question I normally get. How does it pump? And if you go ahead and have it pump like this, there's no problem. If you watch this gentleman here, he's got a bucket and it flips in the air, and this gentleman up top here grabs it and places it. So pumping that way, there's no issues. Or if you choose to pump it this way, you shouldn't have any issues. I don't think they're doing an air test up on that deck there, but in all seriousness, here is the video for the Blue Cross Blue Shield building. If you notice, there is no obstruction, no tripping hazards with the welded wire, and the gentleman with the gaff hook that moves that hose around, there's no chance of him grabbing on that wire and pulling it up. That guy on the edge there, you can see the negative moment on the edge. He made me real nervous, and this is about as close as I got to the edge. I'm not a heights guy, so again, that was up 71 floors. I mentioned we have a engineering department, and we can either take an existing slab and with the traditional secondary reinforcement and give a recommendation for dosage of fiber, or we can start from scratch. And if we do that, we would like to take a look at the fork load loading on that slab, or the post loads from the racks and the spacing of the plates, the dimensions of the plates for shear. We also want to take a look at the vehicular loads and the live load. Again, how I mentioned, the big thing in my world is extending the joints. You might ask why, and it's because of that piece of equipment right there. The hard pneumatic wheel of that forklift, where we join it, it will curl, and essentially that piece of equipment will run over that curled joint and start banging at it and opening it up. And so what we've been able to do is extend the joints and get them into the column line. And it's not as simple as throwing fiber in there. We do have to optimize the mix a little bit and take a look at a few other issues, but we have been able to get out to 60 to 70 feet. Here is a sample of a job at Rinker Boats, and they were having problems with this hauling throughout this. I'm sorry, let me start over. They were having issues with transporting the hulls of their boats with this rack system, and there's steel wheels, and what it was doing was banging on that joint, and it was damaging the hulls or damaging their product. And so we went in and I suggested, let's not join it. Let's go ahead and throw 5 pounds of macro in there. And the guy called me up and he says, oh boy, it's cracked. You got to come out here and take a look at it. And I went over the 3 absolutes in life. It's going to crack. And I threw my crack card down and I said, let's come back in 60, 90 days and take a look at it and measure it. And then we'll come back after the winter. And the bottom line of the story is that they are, every time they do a routine maintenance and they're tearing out slabs, they are going jointless. Again, in my driveway, I want to control where that joint is, but in an industrial application, it's probably best to take a look at going jointless. Here's another a sample or example. This is a aluminum extraction facility. That blue door there is the oven. This is a 35-foot long bed that carries they had an 85-foot and a 25-foot. So this pen is sitting inside the joint, and as you can tell that it is not even touching the top of the slab. Now, obviously, this is a very dirty environment, but they are also transporting their product around with these steel wheels, and as you can see, that going over those joints and damaging it has chipped the wheels, and those steel chips act as grinding agents. And the problem is it goes over the joint and it again starts damaging the product. So we came in with 7.5 pounds of macro fiber and were able to go jointless. And the problem that they were having after we were done is that had to slow down the drivers because they were so accustomed to having it nice and smooth that they were going a little too fast. But those are good problems. This, in my opinion, is the hardest piece of equipment or application on a concrete slab. It's a waste transfer station. The slam drag of that piece of equipment, the drivers will swear to you that they don't spin their tires, but when they go into the pile, they do spin their tires, and whatever's underneath the tires acts as a grinding agent. Plus, you've got whatever gook and everything dripping off the garbage gets in those cracks and will start eating at the concrete and the reinforcement. And I've seen them run on rebar. The issue is that garbage doesn't stop. So long-term maintenance of their slabs to extend the life of it, we've been able to introduce fiber reinforcement to achieve that. Again, I want to take a look at the rack loading. When you look at the joint pattern, we can assist with that because what typically people want to do is say, hey, my vehicular load or my vehicles are going to go up and down those aisles. I'm going to put the joints underneath the racks. Well, you don't really want to do that because that's loading on either side of the panel, and what will happen is that it'll pop in the middle. And so with our engineering department, we can take a look at your rack layout and help you with a joint pattern with that application. Again, taking a look at the uniform load on that slab. So my distribution arm is the ready mix producers. We do not sell direct to contractors, but it's the ready mix producers that I go through. But I also work with the design community and the contractors. Again, I want to make sure that the contractors or my good cooks know what they're doing with the fiber reinforcement. I don't know. My wife says I'm not clear sometimes, and I confuse her. But I don't know if it came across how much I don't like welded wire or rebar, especially when it's on the bottom of the slab. So welded wire, I did find a good application for it, and this was actually a restaurant, a Mexican restaurant, real close to our factory in Birmingham. That's very artistic, or you can go ahead and throw it in some planters or retaining walls. But really, that's the best use for welded wire.